This is probably the most underutilized technology I've seen in a really long time. Please, somebody go and make a multi-million-dollar startup with this thing. Long story short, you can incorporate state-of-the-art AI into your Rust application with very little code and almost no knowledge of machine learning. It's not production ready for all use cases yet, but it's not going to be that way forever, and as the technology improves, it's going to get closer and closer. For example, I might be able to build an automated customer service AI into my Rust application that can not only answer customers' questions, but show empathy toward them and handle potentially unforeseen scenarios. The only input we'd have to give this AI is some basic information about how to respond to the customer and what the customer said. Okay, so how do we build all this? Well, the key components are a criminally overlooked crate called RustBERT, and a company called Luther AI, and a model they created called GPT-neo. Combine them all together and you can have intelligence in your Rust app that appears pretty human for some tasks. Let's back up a bit. Where did all this come from? Well, in 2017, there was a paper called Attention is All You Need that got the attention of the machine learning community because of the new neural network architecture it introduced called the transformer, which achieved revolutionary performance on a language translation task. But it also turns out that transformers are great for other tasks too, like text generation, summarization, and sentiment analysis. Basically stuff that you might otherwise need a human for. A while back, I made a video about OpenAI's GPT-3 platform, which is probably the most well-known way to integrate world-class AI into your application. The thing is, GPT-3 costs money for each API call your app makes to it. GPT-neo is completely free to use under the Apache 2.0 license, which opens up a ton of possibilities, especially for startups that are on a budget. Keeping this as simple as possible, let's look at the small amount of code we need to get this working. I mentioned we're going to use a Rust crate called RustBERT, which is actually a port of a Python library called transformers, which is the go-to library in the Python world for training and making inferences from these transformer-based models. You'll see what I mean in a few minutes. There is one dependency that we need to have installed to get this thing up and running, and that is libtorch, which is basically a C++ version of the popular PyTorch machine learning library in Python. Installing libtorch is going to be different depending on your platform, but if you're on a Mac, you can just do brew install libtorch. Once we've installed libtorch, we need to set some environment variables. So the first one we're going to set is libtorch. We're going to export libtorch, and then you're going to specify the directory that you have libtorch installed in. In my case, it's this directory. And then we're going to add the contents of the libtorch variable to LD library path. So that looks good. This will make it so RustBERT can load the libtorch library when we run our Rust application. Okay, now let's get to the code. First, we'll create a new project called BERT test. And then we're going to add the RustBERT crate to our project. So we'll cd in there. That should do it. Now we'll open it in VS Code. The first thing we're going to do is load the text generation model. And if you're not familiar with machine learning, a model is basically the output of a training process, which is a computationally intensive process that takes example data as input and spits out the model as output. There's a platform called Hugging Face that makes open source models available for anyone to download and use for free, including GPT-neo. Hugging Face also offers a really neat SaaS service, but that's a topic for a whole nother video. There's two main options for loading these open source models. The first option is to have RustBERT download it for you automatically from Hugging Face, and we can do this using the remote resource struct. Alternatively, you can download the models manually from Hugging Face, and then use a struct called local resource and load them from your local machine. You probably want to use local resource in a production scenario, but for experimenting and testing, remote resource is pretty convenient. When loading a model for text generation, there's actually 4 files that we need. The first is a .ot file, the second is a config file, the third is a vocab file, and the fourth is a merges file. It's not important to know what all these do when you're starting out. Just think of all these collectively as the model that we're going to use to generate text. RustBERT has some built-in enum values for the model that we're going to use, which is gpt-neo 27b. So we can see we're creating a box, which you'll see why we need that in a minute. And then in the box, we're gonna add a remote resource from pre-trained, and then we're passing in this GPT-neo 27b model resources value. Just from this, we're telling RustBERT that we want to go and grab the GPT-neo 27b model from the Hugging Face model repository. It's going to download it the first time we run our program, and then after that, it's going to be cached, so we don't have to download it every time we run the program. This particular file is about 10 gigabytes, so the first time you run your application, you might have to wait a little bit. Now we're going to grab the config part of the model that I mentioned. Make sure I import these things as I use them. Then we're going to grab the vocab part of the model. And then finally, the merges part of the model. When we do text generation, there's a lot of configuration that goes into that. One aspect of which is the model that we want to use to do that generation, which consists of the 4 files that we just loaded here. There's a field in this text generation config struct called model type, and we're going to specify model type gpt-neo. And then we're going to point to the 4 files that make up our model that we just loaded. We're using shorthand here, so text generation config has fields called model resource, config resource, vocab resource, and merges resource. And because we named our local variables the same name as those fields, we can use this shorthand here where we just specify the local variable and it automatically assigns the field of the same name in text generation config to the value of that local variable. There's some fields in the text generation config struct that allow you to dictate how inferences are made based on the model, and the values you set for these might depend on your use case, but I think these are some good starting values. When you're starting out, you don't necessarily need to know what these parameters are, but if you're not getting the results you want from the text generation, this is probably where you'd go. You want to go look up what these parameters mean and then start tweaking them until you get what you're looking for. Text generation config has some other fields that we're not going to explicitly set, so we're going to do the struct update syntax here. So we're going to do .default default. This is a way of building a text generation config struct and only specifying the fields that we care about and then setting the rest to default. So this syntax here for any field that we haven't explicitly specified, we'll set it to the default value. And then we're going to import these as we use them. Now that we have our text generation config struct, we can build our model. Not going to do error handling in this video, but in the real world, you'd probably want to handle any errors that happen when you create the model. Import text generation model. Now we're going to intentionally create an infinite loop, which Rust has a very handy syntax for. You don't even have to be bothered to do while true. You can just do loop. That's it. We got an infinite loop now. And this is going to be our read eval print loop. So the first thing we're going to do is take in the user input. When we read in the user input, we're going to use a slash character as a delimiter. So we're going to tokenize the user input based on the slash character. What we're going to do with that is the first token we're going to take and use for what's called a prefix when we generate text. The remaining tokens, so everything after the first token, we're going to use as generation input. And I'll explain more what that means when we do the demo here. But for now, we're just going to split the user input based on the slash character. So now that we have a split, we're going to create a slice from that split. Then we're going to perform the text generation. And again, we're going to pass in all the tokens after the first one as the input to the generation. So we're going to take element 1 of the slice and everything after that. That's the syntax to do that. And then the second argument to the generate function is actually the text generation prefix. So we're going to pass in the first token as the text generation prefix. That should do it. So now we've generated our text and all we need to do is print out the output to the console. And output is in the form of a collection of sentences. So we're going to loop over those and print them out. That should do it for the code. Let's test this out. We'll jump to the terminal first, make sure we're in the right directory. Yes, we're in Bert test, and then we're going to do cargo run. So I already have the GPT-neo 27B model downloaded, but if you're running this for the first time, this is the point at which it would start downloading that 10 gigabyte model. So it'll show that in the console. You'll see what it's doing, but just expect to wait a little bit for that model to download the first time you run this. I mentioned this before, but if you're in a production scenario, you probably don't want your production machines grabbing the GPT-neo model from Hugging Face every time they redeploy. In that case, you probably want to use the local resource and have the model built into the Docker image or whatever you're using. So yeah, in a production scenario, you'd probably want to use local resource instead of remote resource. I mentioned we're going to split the user input based on the slash character, and the first token is going to be used as a prefix for the text generation. The distinction between the input to the text generator and the prefix is that the input will be included in the output. So when I want to generate text, I type something that I want the text generator to complete. I could say Bob looked, and I might expect the generator to say Bob looked out the window. So in that case, Bob looked would be the input to the text generator. If I want the generator to know that it's raining outside, but I don't necessarily want that to be included in the output, I would use that in the prefix. So for a prefix, I would specify it was a rainy day, and then for the input to the generator, I would say Bob looked. So let's try that out. And then I separate these two with a slash, and then Bob looked. So what I would expect the generator to do in this scenario is to generate text that comes after Bob looked. So it'll include Bob looked in the output, but I want to tell the generator that it's a rainy day. And I would hope that it incorporates something about the rainy day in the output, but not explicitly say it was a rainy day in the output. So let's try this. GPT-neo does benefit from CUDA acceleration. So if you have a GPU in your machine, that'll make this a lot faster. But if you're using CPU only like I am, this might take a while.
One eternity later.
Okay, perfect. And we got pretty much what I was hoping for. Our prefix was it was a rainy day, and then our input to the generator was Bob looked, and the output it came up with is Bob looked out of the window and saw that the rain had stopped and the sun was shining brightly. That's perfect. We set our max length to 100, so the generator could potentially ramble on for a while. You can limit how much it'll say by adjusting that maximum length. In our case, it kind of rambles on. I'm glad he said to himself, this is going to be a good day. For me, I have a lot of work to do, and I want to get it all done before the rain comes back again. Then I can go out and play ball with my friends and have lots of fun. That seems very reasonable based on the input. And then it gets cut off on the next sentence. It will be, and then it hits that max length. So it does stop kind of abruptly based on max length. So if you're using this in a real world situation, you might want to kind of identify what the last complete sentence is and just kind of discard everything that comes after the last complete sentence. So in this case, I would just discard it will be and use what came up to that point. Again, depends on your use case, but I think in most cases you'd want to do that. So what I'd probably do if I was building a customer service representative is in the prefix, I would explain how we expect customer representatives to speak to customers. I would probably give some specific examples of representatives talking to customers. Customer has a specific problem, representative responds, and the generator will leverage those examples in its output. The potential for this technology is pretty incredible. I'm actually very shocked at how underutilized it is. It's not perfect yet, but there are a lot of things you do with it in its current state that just isn't being done yet. So please, somebody go and build something with this. Let me know in the comments if there's something specific you're planning to build with this, or if you have any good ideas, or if you're not sure if this is going to work for an idea that you have. I'm curious to see what you all think of this. There you have it. That's a quick way of incorporating world-class AI into your REST application. You might have to do some tuning to productionize this, but this example is a good starting point. Hope you all liked it, and we'll see you in the next one.